All right, now let's get into the specific hormones. Let's highlight some of them, emphasis on some of them, because the fat cells are fantastically complicated. That's not the right word. They are fantastically involved endocrine glands. So they secrete a lot, dozens of hormones. And we don't have time to go into all of them, and many of them are kind of boring. So I wanted to just highlight the 6 or so most compelling and the ones you might be familiar with, and or the ones I think you should be familiar with. All right, the first hormone from fat cells is probably the most famous. To my knowledge, it was in fact the first discovered hormone, namely leptin, from the Greek word leptos, which means thin. Now, the story behind leptin is actually quite interesting, and let me, just for kicks, elaborate on it, although I wasn't planning on doing this. It's just so interesting. So leptin was discovered in this very large mouse colony housed within a lab. This was a lab on the East Coast at a university, and they found that some of the animals were really, really fat, and they were insatiable with their appetite. They would not only eat all the food you gave them, they would also be nibbling on the pellets, the wood. They would eat their own waste. They were just insatiable, and they would become these fantastically chubby little mice. When they dove into this a little more, they found that there was a particular hormone that was expressed differently in these animals. Indeed, these animals appeared to have little or none of it. And that was what they called leptin. Now, the story ends up getting a little more complicated, including they, of course, patent this. They start producing it. A drug company buys the rights and begins going through clinical trials to test the efficacy of leptin at mitigating human obesity. And it just totally crashes and burns for reasons that we're going to get into now. Why is it that treating an overweight person with leptin doesn't help? It's because they already have a lot of it. And so let's talk about leptin. So leptin's most famous effect is to suppress appetite or to promote satiety by acting centrally in the brain, in the hypothalamus. But it goes beyond that. Most people, even highly educated people, don't know that leptin actually has systemic effects. It increases fatty acid oxidation. It increases mitochondrial biogenesis in the muscle. So it promotes insulin sensitivity. So the leptin has many more effects than just the central effect on satiety that are all very relevant. A totally unappreciated effect of leptin is how completely essential it is to tell the hypothalamus to create the first hormone called gonadotropin releasing hormone, to tell the pituitary gland, which in turn will tell the gonads when it's time to actually be fertile. So it is leptin that explains why, in particular, a young woman or even an older woman who's too thin, who doesn't have enough fat tissue, that they will not be fertile. They will not ovulate and have no menstrual cycle. So again, this is why if someone gets too skinny, especially a young woman who's more sensitive to leptin and needs it more, they will not ovulate. They will not menstruate. They will have no menstruation, no menstrual cycle if there's not enough leptin. So as much as we talk about leptin in the context of metabolism, we could also talk about it completely in the context of fertility, because no leptin means no fertility. And let's just pause for a moment and appreciate how genius this is.
Yes.
Leptin is a signal that comes from the fat tissue. And thus, it kind of becomes a way for the fat tissue to tell the brain that the body has enough fat, enough energy stored that it can undergo the energetically rigorous process of fertility, of getting pregnant. After all, the female body has to carry the metabolic burden of pregnancy and even the metabolic demands that come with lactation, which is considerable. So all of that fat tissue is essentially her body's way of telling the brain that there's enough energy to reproduce. So leptin is completely essential with reproductive health. Leptin is also relevant with bone health and bone recycling, the formation and the remodeling of the bone, another totally overlooked effect of leptin. So a lot of systemic effects that have nothing to do with satiety and hunger. Okay, now one final note, then I'm going to do this with each of the hormones we cover. And this is totally unique. And no other endocrine glands will change the production of its hormone based on the size of the gland. So, for example, if you have a thyroid gland that gets bigger, it's still producing abundant thyroid hormone. If the adrenal glands somehow got bigger, it still is producing the adrenal gland hormones, which are a lot. But when it comes to fat tissue, and leptin in particular, as fat tissue goes up, so too does leptin. So as fat cells in particular are growing, undergoing hypertrophy, leptin levels will continue to go up. That's not a great thing. Now, I just got done elaborating all the ways in which leptin has metabolically favorable outcomes. And now I'm telling you that it's not a good thing. It's because too much of a good thing can become a problem. Namely, the body starts to become leptin resistant. Leptin resistance with too much leptin. That sounds familiar because the same thing happens with too much insulin. Too much insulin causes insulin resistance. The same thing happens with leptin. As the fat cells swell ever larger, their production of leptin grows ever higher, and the body becomes resistant to it.